Today we're going to do winds part 2 in this video. Just a quick review. The most important behavior factor when we're talking about wildland fires is weather. Test question. And then all weather is caused by or originates with the sun. Test question. Okay, so then the sun radiates to the earth and the earth reacts to that. We saw that only 50% of that radiation actually, on a regular basis, as an average, 50% makes it to Earth and strikes the Earth. Now, when the radiant heat hits the Earth, well, it's all dependent on the angle of the Earth, the time of day, the time of year, where we are in relation to the sun. Part of the year we're closer to the sun, part of the year we're further, part of the year we're getting less sun because during the winter we have longer nights, shorter days, and it also depends on where you are on the earth. The equator gets way more sun than the polar caps, and we're right in between. So all of these factors play a part in how the earth then reacts. We also talked about lag time, that reaction takes time because the earth absorbs the heat depending on all of those factors we mentioned, plus what kind of vegetation is in that area, the topography of the area. Is it a south aspect, a north aspect, east or west? All of these factors then have to do with how much of that heat the earth absorbs and then reflects back into the environment. So the most amount of radiant heat that we get is normally around noon, when the sun is at its zenith with straight rays coming at us instead of angled rays. But that's not the hottest time of the day. It's more like 3 o'clock. So we've seen that lag time factor plays. Now, because of the unevenness of that heat upon the earth, we saw in our winds part 1 that it creates hot and cold pockets, and we call those high pressure and low pressure. High pressure ridges, low pressure troughs, and these pockets of air move around depending on the Earth's rotation, where air is hot and rises, and where cold air is cold and sinks and comes down. So all of these factors go together to make winds. And wind goes, remember, we talked about wind, and it's very important in this particular lesson that you remember this part, that wind goes from high pressure to low pressure. And the wind goes clockwise around high pressure and counterclockwise around low pressure. So where those pressure fronts, where those pressure zones or pockets meet the edges, that's where oftentimes we get severe weather. As I'm making this video, we're facing fall. Fall's right around the corner. And in the fall, one thing that happens in the Midwest and more in Middle America than anywhere else is we start getting tornadoes. And why do we get tornadoes? Because we're still getting cold air coming down from the Arctic, but now we're getting hot air coming off of the Gulf. And the hot air and the cold air meet, and they don't like each other. And that's where we get hail, lightning, and cyclones or tornadoes. And this happens in the spring as well too, but mostly we see a lot of this in the fall. So just that's part of the what we're going to talk about today is where we have problem winds. So there's 4 wind conditions that are especially dangerous to firefighters. The first one is we've talked a lot about already, so we're just going to kind of skim through it again, but cold front winds. The second one, we've mentioned it, but this is really important if you work or live in Southern California, and that's Foehn or gravity winds. Some people pronounce it Foehn, but actually the right way to pronounce it is Foehn, like you're German. Foehn. It's a German word. Third one is wind associated with thunderstorms, which could be part of a cold front, but there are other ways that thunderstorms are manufactured or that they happen, occur. There are other conditions. So thunderstorms in general is something we need to be aware of. And then lastly, we'll just briefly talk about whirlwinds, dust devils, firewhirls, which are basically all the same thing, cyclonic action. So let's start talking about cold front winds and just kind of review what we already talked about, maybe add a little bit extra. A cold front is the boundary between two dissimilar air masses where the encroaching air mass is cooler. Now, hopefully you watched those videos from YouTube where it talks about how the cold air goes under the warm air or goes over the warm air. You know, it depends on whether it's a warm front or a cold front, but and how that works and what happens as a result of those two fronts colliding, and where you get these thunderstorms that can happen as a result, but most importantly, we get wind changes that are dramatic as a cold front passes. You can go on YouTube. I didn't include them because some of them are really long, but there are some time-lapse videos. I did show you the one where a cold front comes in and you can see the weather vane where it goes from pointing in one direction to the 180 degree the other direction, and it's violent, the changes that are going on. They can adversely, of course, affect fire behavior as much as 10 miles away. They move at about 20 to 30 miles per hour. So when a front like this moves into your area, you need to be aware. Now, sometimes you can see them, but sometimes you can't. And like I said, if it's 10 miles away and you're near an area where you're obscured from seeing that part of the sky, you still might get radical wind changes. So be aware of that. A dry cold front is not even going to show itself. It doesn't have the clouds. So how do you know when cold fronts are coming? Your weather reports, okay? Pay attention to the weather reports that come over the radio or the mobile data terminal, and especially pay attention to those weather reports in the morning, but throughout the day. So, several reasons cold fronts are dangerous is those rapid wind shifts we talked about, strong gusty winds, and the thunderstorms that can be related to it, and we'll talk about it again. But as we move on to thunderstorms, what's the biggest danger with thunderstorms? Yes, lightning is a concern. Yes, the rain and the hail is of interest to us. But the most concerning are the downdrafts because they can push wind in 4 different directions and they can be very violent. So also there's oftentimes with cold fronts, there's a considerable drop in relative humidity. And this is going to affect our fuels. So cold fronts need to be watched. Okay, our second type of wind, I know we just raced over that, but we've already really talked about cold front winds. Foehn winds. Now, again, firefighters argue about whether it's pronounced Foehn or Foehn. Well, I looked it up and used one of those apps on the internet. How's this word really supposed to be pronounced? And it's Foehn. You know, it has to be said like you've got a German or a French accent or something. Foehn. So it's like you're clearing your throat. Like Gollum in Lord of the Rings. So it's a weird word, but Foehn winds, I'm just going to pronounce it the way I like to say it, Foehn, are warm, dry winds that occur when air spills over high elevations and moves downhill. Now, we have Santa Anas. But there are other Foehn winds around the country and throughout the world because it's related to these conditions where you have a high that goes up against the mountains and you have a low that is away from it and what would be topography-wise downhill. So the wind goes from the high to the low, and as it goes down in elevation and down from high pressure and higher elevation down to lower elevation, it gets compressed and there's a friction effect and it warms and dries as it goes. So this is what we know as Santa Ana winds here in Southern California. The winds become warmer and drier. Don't believe the wives' tale that it gets hot and dry because it goes over the desert. That's not true. It's because of friction and compression. As it comes down in elevation and as it funnels through the canyons. So the wind comes all the way from the Rockies and the Great Basin, goes over Nevada, goes through our deserts, and then it hits the Angeles Crest and the Los Padres National Forests or those mountain ranges, and then it comes down our canyons. Where do we get our worst Santa Anas? Well, in some of these bigger, more substantial canyons. In La Cañada off of the Arroyo Seco, out in the San Bernardino area, I'm forgetting the name of that town, Devore. Devore has just ridiculous Santa Ana winds. And on the 15, big trucks, going up the 15, they're not going to Vegas. Maybe they are, but they're just, trucking. But if they're there when these Santa Anas hit, it'll blow them right over. And you can see on the internet pictures of trucks being blown over from the Santa Ana winds in that, I believe they call that the Cajon Pass. The Cajon Pass is pretty bad too, but nowhere near what the Cajon Pass and the Arroyo Seco are. So as the Foehn wind flows down slope, it's compressed, it gets warmer, it gets drier, it gets faster, sometimes 50 to 70 miles per hour. I don't have really time to tell the whole story, but when I was a young kid at my family home in La Cañada, we had a 6x12 header that my dad was going to use to build my sister a mega, not dollhouse, but a playhouse. And this was being built better than most people's sheds. And it was pretty amazing. But we had this about 8 to 10 foot long, I think it was 8 foot long, 6x12 header. And the wind picked it up, rolled it or picked it up, and took it from our yard into our neighbor's yard. It took my neighbor, my dad, both of my brothers, and myself, but I was pretty young. I probably was not very much help, but to bring it back. So it took 4 men to carry it, but the Santa Anas picked it up and rolled it into my neighbor's yard. So they're substantial in speed and in strength. So as I already said, they're created, if you look at the video that I'm going to put on here about Santa Ana winds and how they're developed, you'll see the map that shows a high pressure over the Great Basin, which is Utah, up against the Rockies, and you'll see a low pressure down off of the Pacific Ocean, either off of Baja or off of California. And that creates a gravity wind, and it's also called katabatic winds by meteorologists. So it's a going down kind of wind. So it gets heated and dries as it crosses the coastal mountain ranges. And an important thing to remember about Santa Ana winds is the thing we call battling winds. And we might talk about this a little bit more later on. But battling winds are a big issue. They were a huge contributor to the men that died in the Loop Fire in the Sylmar area and the Glendale firefighters and LA City firefighters that were burned in the Calabasas fire back in the 90s. As the Santa Anas, that condition, as the high moves over the Rockies and the conditions that make for those winds subsides, we go back to our normal local diurnal winds. So the wind wants to go inland, up, right? As the sun goes up, the winds go up. We talked about the wind goes up canyon, up valley, up slope, and it starts going back to normal. There's usually going to be a lull in between. The Santa Anas start to die off, and there's this battle for supremacy. A lot of times, inexperienced wildland firefighters will go, oh, this is great, there's no wind. And they're not thinking about the fact that the wind is just going to change directions. So they can abruptly change 180 degrees in a new direction. And this can ruin your whole day, like it did for the Glendale firefighter at Calabasas, who was severely burned when the wind shifted and the fire had been punking around down in a canyon, and it had just slowly been creeping towards this southwest aspect. And around 4 o'clock, worst time of day for fire on a southwest aspect, the breeze started to blow up canyon. So now you have the fire has the slope to its advantage. It has the aspect preheated fuel to its advantage and the wind to its advantage, and it rushed up this slope and burned this firefighter. Okay, so wind, aspect, and slope in alignment are killers. Here's a picture at the old fire. You can see how the smoke is not going up, it's going sideways, and this is a typical Santa Ana fire. I love this illustration. This is when they had the old fire. Of course, October is one of our worst months for Santa Anas. We can get them all the way through January, but this particular Santa Ana was quite extreme, and we had the Otay fire, the Cedar fire, the Robler fire, the Old fire, the Grand Prix fire, and in Simi, we had the Simi fire that burned all the way. I forget that. I think that one started on the 126 and burned all the way to Simi. So yeah, pretty amazing. So there's a video that I'm going to put on there. It's here if you want to write this down, but that explains how these Santa Anas occur. Now, mono winds are just another kind of Santa Ana wind that happens up in Mono County, Northern California. So they affect like the areas around Yosemite, and they've had winds that have been clocked at 100 miles per hour in the Yosemite Valley. And it's the same effect. High pressure over the Great Basin, low pressure off of the coast. Now, when we see mono winds and north winds, we'll look at that in a second. Mono winds and north winds are an indicator we're going to get Santa Anas, because it's just working its way down from Northern California now to Southern California. Chinooks occur in the Rocky Mountains. They're similar, but they're going to affect other parts of the country because they go down, they blow out of the northwest and up the western slopes, and then they race down the eastern slope. So they affect the east side of the Rockies, Chinook winds. If you ever end up on a crew out in Idaho, Wyoming, Montana, Utah, Nevada, Utah, Colorado, you will be familiar with Chinook winds. North winds occur in Northern California, and usually they're an indicator that within the next week we're going to get Santa Anas in Southern Cal. Eastern winds occur in Washington and Oregon, and they affect fires up in the Cascades and are a similar, again, effect. Now, unsimilar, different than Foehn or gravity winds is sundowners. Sundowners is a very unique effect that basically happens in Santa Barbara and nowhere else in California. They are not a Foehn wind, but they have a notorious, they're infamous, right? That word is often used wrong. Infamous means famous in a bad way. So you don't use infamous when you're talking about somebody that you think is awesome. You wouldn't say Kobe Bryant is infamous, right? He's famous. He was one of the greatest basketball players of all time, right up there with Michael Jordan. But you don't call him infamous. That actually means he's negatively famous. Sundowners are infamous. They have created enormous fires, and usually in the Montecito, Santa Barbara area, where homes are gazillion dollars in value. So, the last big one threatened Oprah's home, Kenny Loggins' home. You guys probably don't even know who that is. A bunch of famous people. So they happen when you have very high daytime temperatures in the Central Valley. Then the coastline is oriented approximately west to east. Not south-north. So there's, at that part of the coast, when it's different than what you're expecting. And the sundowners usually happen late in the afternoon. And what it is, it's kind of a battling wind kind of situation. Because of the really hot air in the San Joaquin Valley and that little valley on the, that's, between the San Joaquin and Santa Barbara, there's this heat, and it's kind of coming up and over the mountains, the Los Padres range, and it's trying to come down, but there's cold air coming off of the ocean and fog. And there's actually videos out there of this fog going back and forth, time-lapse videos. And eventually, at the end of the day, it gets hot enough to push that fog and that cold air away, and the winds descend, and it happens around sundown, and will then continue for the rest of the night and the next day, oftentimes. And so their onset is typically associated with a rapid rise in temperature, an enormous decrease in humidity, and in our most extreme wind events, they can be gale force or higher, and we have horrible, horrible fires in the Santa Barbara area. I missed being on the Painted Cave fire by about 10 minutes. We were at another fire. Our captain didn't put us available. We were part of the strike team that was supposed to go, and they did go, and they filled our spot with somebody else because while we were just mopping up, we were just putting the hose away. We were ready to go. He didn't put us available because he was the kind of captain that didn't want to go available as fast because you might get on another incident. So he was lollygagging, and we didn't get to go to one of the most infamous fires in the last 50 years. So, hey, let's finish up here. Thunderstorm downdrafts. We've kind of already talked about this. So if you're fighting fire in an area where there's thunderstorms, whether it's from a cold front or there are other ways that thunderstorms are developed, and when we talk about clouds, we're going to talk more in detail about this. But most of the time, it's from heat rising. Okay, so in August, we get thunderstorms over the desert or over the mountains from heat rising. And you do need to be concerned about lightning. When you start hearing thunder, you need to be, your danger ears need to be on. It's very dangerous, and it can't be stressed enough. So thunderstorm downdrafts are usually, the thunderstorms themselves are formed by solar heating most of the time. So there are other things that can cause it, like cold fronts. But as the hot air gets pushed up or rises because of convection, the thunderstorms can rise up to 40,000 feet. And the hot air rising, the cold air is attracted, and if you watch the video about cold fronts, warm fronts, you need to watch that. You'll understand this really well. And it condenses, and it gets to the point to where it can't hold the moisture, so clouds start to form. The higher elevation clouds are up in air that's so cold. As it transfers in elevation, the air gets colder and colder, and this moisture becomes like they're ice crystals in the sky, and that's why they have that cotton candy look to them. It's ice. It's not just water in the moisture. So as that heat develops, and goes up and cools off. Then it gets heavy with moisture and heavy in the sense of cold, and then we get those downdrafts that we've talked about. And the energy that's in there is the source for lightning and hail and all of that. And I've been told by meteorologist friends that the energy in there is equivalent to the amount of energy in an atomic bomb. So when they collapse, that cold air comes down, and as we already talked about, it can go 4 different directions at once. So cooling makes the air heavier and accelerates its downward movement. And like I said, with cold fronts, it can affect a fire up to 10 miles away from the storm. And these winds can be 25 to 30 miles per hour. So one way to tell that it's 25 miles per hour or more is if you see a flag in the area and it's standing tall, it's in the 25 to 30 mile per hour zone. So when they collapse, we get these downbursts, and we might have virga underneath, but the downdrafts are the greatest threat from thunderstorms. Test question. Thunderstorms have a life expectancy. They always eventually diminish at the end of the day. As the day cools off, then they go away. And then the whole process will start again the next day if it's as hot. So again, here's a video that sometimes we watch. These videos are time-lapse videos of the development of thunderstorms. They're really cool to watch, and I'll put them in our set of videos. So what are the indicators of a mature thunderstorm that's about to collapse? Is the virga that we might see, and you might see a rolling underneath it. But also, if you start to see dust clouds here and there on the ground, well, that's an indicator that it's collapsed. Okay, the last couple of slides here are about whirlwinds, dust devils, firewhirls. These are all just cyclonic action, and mostly they're caused from convective currents and updrafts, but they also can be caused by conflicting winds. We'll have places where canyons meet, where oftentimes we get cyclonic action because of wind that's hitting each other, one going one way, one going the other way, and you get either eddies, which is a rolling action, or cyclonic action, which is whirlwinds. So they can occur mostly in clear skies. They can occur as a result of the heat of a fire. And I'm going to put some videos of firewhirls in our list of videos. So on the backside of a ridge, sometimes we get on the lee slope. That's so the windward side is where the wind is coming and hitting that side. The lee side is the sheltered side. So sometimes the wind comes up and over, and then it rolls, and you might get like an eddy effect. So dust devils are just cyclones or whirlwinds that are kicking up dust. So there's a picture of a typical dust devil in the black or in an area that's already burned. And it's just from that heat that's rising, and there's another dust devil. Now, as cool as it is to look at these, don't be mesmerized by it, because this can be picking up burning embers and spreading it. And then also firewhirls. Again, firefighters have this tendency to just gawk at these things because they're so amazing and so mesmerizing. But it's an indication. Listen, these can pick up. And one firefighter story that used to be on the internet, and somebody made them take it off because they thought it was too gory. I don't get it. It was an educational thing, but this firefighter, 2 firefighters actually got picked up by this whirlwind and thrown across this firewhirl actually crossed a road. They were there to try and keep it from crossing the road, but the firewhirl went across a road. It had so much burning material in it as the cyclone hit raw dirt, it didn't die down. It continued to burn and went across and picked up these guys and now had new fuel and continued. And the guy said he was like Dorothy and the Wizard of Oz. He was up in the air, and then it threw him out of the fire. He was badly burned. In your book, the pictures that we saw in chapter 1 of the guy with the burnt arm where you could see where his t-shirt was, That's the guy that was picked up by a fire whirl. So they can go to thousands of feet high and contain tons of hot gases, flaming and burning material, and they lift firebrands and then spread them. And so they can spread fire to areas where you weren't expecting the fire to spread, and it can go out on your flanks, and now you've got a whole nother situation. Okay, that's it on wind part 2. I tried to talk as fast as I could. Have a great day, and watch the other support videos.